Hello, grade 10. This is our second online lecture for semester 4. As I told you in the first lecture, that I've split the lesson into two parts, part A and part B. I've already explained part A and now I'm going to continue and explain part B. I'm going first to make a quick revision for what we have learned, and then I'm going to continue. Our objectives for this video is to study the relative position of two lines and to find the coordinates or the point of intersection of any two lines, and to find an equation of a line passing through a point and parallel to a given line. And now let us make a quick revision for what we have explained in the first video. First, we are going to remember how do I make or how do I form the parametric equations of a line. And we said that in order to create a parametric equation, first you should have a vector am where a and m belongs to this line. So a and m belongs to this straight line. The coordinates of a are given, but the coordinates of m are x and y. So m, any point on the straight line that has coordinates x and y. So we create the vector am that belongs to the straight line, and we should have a directing vector for the straight line. So v is a directing vector for this straight line. And now we already know that am equals tv, where t is any parameter that belongs to the real number. So am could be 2v, could be half v, so t could be any number that belongs to the real number. So that's why we created as a letter. So you can replace it by any letter you want, m, n, a, whatever you want, as long as it's any parameter. And now, following the rules of vector, am equals tv, x minus x0 equals t alpha, y minus y0 equals t beta. So x alone and y alone. And now you move the point x0 and y0, the coordinates, to the right, so you will get a parametric equation x and y as parameters t. Okay? So this is the parametric equation. Let us take a quick example. Suppose you have the point B, which is minus 5, 2, and the vector V, 3, 4. So V is the directing vector and B is any point that belongs to the straight line. So what we should do is to put any point M that has coordinates x and y and create the vector Bm. So M, it has any coordinates x and y, and create the vector Bm. So Bm xm minus xb, ym minus yb. So it's x plus 5, y minus 2, and then you do Bm equals tv. So as you see, x plus 5 equals 3t, y minus 2 equals 4t, and then you order them in this way. And this is the parametric equation. And the second thing we learned about is to find the Cartesian equation of a line. So there are two forms, the parametric equation and the Cartesian equation. And now the Cartesian equation, the first case, if you have a given point and a directing vector. So as you see in the figure, we have a point A that belongs to the straight line D and a directing vector V. As we did in the previous example, we create a point M, which is any point on the straight line D that has coordinates x and y, and create the vector am, x minus x0, y minus y0. And you know that the vector am and the vector v are collinear. So we apply the rule of collinearity that says x y prime minus x prime y equals to 0. So again, we follow the rule of collinearity that says x y prime minus x prime y is equal to 0. Okay, so after doing this, you will see that this is the general form of the Cartesian equation ux plus vy plus w equals to 0, or ax plus by plus c equals to 0. And in this case, v, which is minus vu, is the directing vector of D. So pay attention. The directing vector in the parametric equation is AB, where A and B are the coefficients of the parameters. While in the Cartesian equation, the directing vector is minus vu or minus BA. Let us take an example. Suppose we have a point A and a vector V, and we need to write the equation in its general form. So we create AM, which is the vector that belongs to the straight line D, x plus 2, y minus 3. And we know that AM and V are collinear, so we are going to apply the collinearity, which is xy prime minus x prime y equals to 0. And then this is the general form of the Cartesian equation. If you want to check that your answer is correct, pick out from the equation the directing vector, which is minus BA. Minus B. B is the coefficient of y, which is minus 2. And minus 2 is 2. And A is minus 5. So 2 minus 5 is a directing vector, which is the same as the given. And now the second case to find the Cartesian equation of straight line D. In the first case we had a given point and a directing vector. In this case we have 2 points. So if I have 2 points, for example A and B, so what I need is a directing vector and a vector AM or BM that belongs to the straight line D. So it's very easy. So the first thing I'm going to do is to create the vector AB that belongs to the straight line, or we can pretend that it's the directing vector, and AM in this case is the vector that belongs to the straight line. And AB and AM are collinear, so we are going to apply now the rule of collinearity, and this is the Cartesian form of the straight line. So only the trick in this question is to know how to find the directing vector and how to create a vector that belongs to the straight line. So after we are done from revising everything, so the most important thing is that you have to keep in mind again and again is to know that there are two forms of straight lines, the parametric and the Cartesian, and the directing vector in the parametric equation is AB, where A and B are the coefficients of the parameter, and the directing vector of the Cartesian form is minus BA. Now we are going to learn the relative position of two Cartesian straight lines. So now we are talking about Cartesian straight lines. We are going to learn when do I say that two straight lines or two Cartesian straight lines are parallel, when they are, for example, intersecting, or where they are confounded. So let us start. Suppose we have those two straight lines, D and D prime, in their general form, which is ux plus vy plus w equals to 0, and u prime x plus v prime y plus w equals to 0, or ax plus by plus c equals to 0. So u, v, and w are belongs to R, so they could be any value. Okay. So we are now discussing if u over u prime is not equal to v over v prime, then the two straight lines are said to be intersecting. So if u over u prime is not equal to v over v prime, then the two straight lines are said to be intersecting. Let us take an example. Suppose you have d, which is x plus 2y minus y equals to 0, and d 2x minus 3y plus 3 equals to 0. If you put u over u prime, or the coefficient of x, 1 over 2, 1 over 2 is not equal to minus 2 over 3. So in this case, D and D prime are said to be intersecting lines. Okay, let us take the second condition. If U over U prime, it is equal to V over V prime, but it's not equal to W over W prime, then the two straight lines are said to be parallel. Let us take an example. Look at those two straight lines. 1 over 2 is equal to 1 over 2, but it's not equal to minus 1 over 3. Then those two straight lines are said to be parallel. Now, if the three ratios, as you see, U over U prime and V over V prime and W over W prime are equal, then the two straight lines are said to be confounded, as you see in this example. So if I just put them, all of them, over each other, the ratio is 1 over 2, then the two straight lines are said to be confounded. Now we are going to discuss the relative position of two reduced straight lines. So suppose I have D, which is y equal ax plus b, and D prime, which is y equal a prime x plus b prime. If a is not equal to a prime, then those two straight lines are intersecting, and this is an example. 1 is not equal to 2, then the two straight lines are intersecting. But if a equals to a prime and b is not equal to b prime, then the two straight lines are parallel. As you see in this example, they have the same slope, so definitely they are parallel. And in the third case, if a equals a prime and b equals b prime, then those two straight lines are confounded because they have the same coefficients. And as an example, y equal to x minus 1 and y equal to x minus 1 is the same straight line, so they are equal. Then we say that they are confounded. Now we go for the third discussion, which is about two parametric straight lines. Okay, so if I have two parametric straight lines and I'm going to discuss their relative position. The first case, if alpha over beta, so the coefficient of the parameter in the first straight line, is not equal to the coefficient, to the ratio of the coefficients of the parameter in the second straight line, then those two straight lines, we say that they are intersecting. Let us take an example. Look at these two straight lines. The coefficients of the parameter in the first straight line are 1 and 2. So I'm going to put 1 over 2. 1 over 2 is not equal to 3 over 2. Then the two straight lines are intersecting. Okay? But if those two are equal and they are not equal to the third ratio, which is x prime 0 minus x 0 over y prime 0 minus y 0, then they are parallel. So let us take an example. I have those two straight lines. I'm going to put the coefficient 1 over 2. Is it equal to 2 over 4? It is equal. So they have the same ratio, which is 1 over 2. But they are not equal to the ratio of x prime 0, which is 1 over 2. It's not equal to minus 4 over 1. So as you see, they are not equal to the third ratio, so only the first two are equal, then the two straight lines are parallel. But if the three of them are equal, then the two straight lines are confounded, as you see in this example. So 1 over 2 is equal to 1 over 2 is equal to 1 over 2. So we say that those two straight lines are confounded. And now to prove that two lines are orthogonal, you need to find the directing vector of each straight line and find the dot product, which is x prime plus y prime. If it's equal to 0, then the two straight lines are orthogonal. So again, if I have two straight lines and I need to prove that they are perpendicular, you have to pick out the directing vector of each straight line. You should do the dot product. If it's equal to 0, then they are orthogonal. And now suppose that two Cartesian straight lines are intersecting. So we already proved that they are intersecting, and we need to find the point of intersection. How can I find it? Okay, so suppose that, for example, those are two Cartesian straight lines. How can I prove that they are intersecting? We already learned u over u prime. If it's not equal to u prime over v prime, then they are intersecting. Or in another way, you can find the directing vector of each straight line. So the directing vector of the first one is 1, 1, 2, which is minus BA, and the second one is minus 1, 3. If we make the dot product and it's not 0, then they are intersecting definitely. So if you do the dot product, it's not 0, so they are intersecting. And to find the point of intersection of those two straight lines, it's enough to solve this system. So 2x minus y equals 3, this is the first equation, and 3x plus y equals 2, this is the second equation, and you solve it. It's a system of two equations, two unknowns. You already know how to do this. So you get rid of the y, you find x, and then you replace it in one of the equation to find y. Therefore, the point of intersection, which is I, is 1 minus 1. But what if I have two parametric equations and I need to find the point of intersection? So, for example, suppose we have those two parametric equations, and the directing vector of the first one is the coefficient of the parameter, which is 2, 1, and the second one, the coefficient of the parameter, which is minus 1, 3. If you do the dot product, you are going to get a number which is not a 0. So definitely we already know that they are intersecting, and I need to find the point of intersection of those two straight lines. What I'm going to do is I'm going to put x equals to x and y equals to y. Both of them we are going to put it. X equals to x and y equals to y, because the point of intersection, it belongs to the two straight lines. Okay? So after ordering this system, you are going to get 2t plus t prime equals to 6 and t minus 3t prime equals to 3. This is a system of two equations with two unknowns. So you solve it normally, you are going to get t equals 3 and t prime equals to 0. And now, if you replace the value of t in the first equation, or if you replace the value of t prime in the second equation, in both cases, you are going to get the same answer, which is I, 5, 0. Okay, so whether you replace t in the first equation or you replace t prime in the second equation, you are going to get the same point of intersection, which is 5, 0. And now we are going to find the equation of a straight line which is parallel to another line, but it passes through a given point. So the given is, this is the given straight line D of equation 2x plus y minus 5 equals to 0, and the point A, 1, 1. We are trying to find the equation of a straight line that passes through A and parallel to the straight line D. You should know that if two lines are parallel, then they have the same director vector V. Okay, so again, if two straight lines are parallel, then the two straight lines, they have the same director vector v. So the first step I'm going to do is to pick out the directing vector of the straight line d, which is minus 1, 2. And then, as we learned, we are going to express a vector am, where m belongs to the straight line, and vector v, they are collinear, so we apply the rule of collinearity, which is xy prime minus x prime y equals to 0, and that's the equation of the straight line. So the key word in this example is to know that if two straight lines are parallel, then they have the same director vector, and you can use it to find the equation of the new straight line. And now what if I have a parametric equation and a point A, and we are asked to find the equation of a straight line passing through A and parallel to D. The same concept, we are going to pick out the directing vector of the straight line, which is 1, 3, and as you see, the parallel to D is defined by a point and a vector, and AM and V are collinear, so you apply the same rule, but as you see, I'm not going to do the collinear, I'm just going to make them AM equals alpha V, as we learned how to do the parametric equation, and after ordering them you are going to get x equals alpha plus 2, y equals 3, alpha plus 3. You can replace alpha by any parameter as long as it belongs to the real number r. Now what if I have a straight line passing through a given point and of a given normal vector? What's the meaning of a normal vector? Actually, a normal vector is a vector which is perpendicular or orthogonal to the straight line D. So the normal vector is perpendicular to the normal vector D. It's very easy. You create, as we learned, the vector AM, which is where A and M belongs to the straight line D, but we are going to do the dot product of AM and N, and we already know that it's equal to 0. Why? Because the two vectors are orthogonal, and we learned this before, that if two vectors are orthogonal, then their dot product is equal to 0. So x prime plus y prime equals to 0. So as you see, when I do the dot product, I'm going to get the equation of the straight line of D. Okay? And the last thing we are going to talk about is the distance from a point to a straight line. Suppose you have a straight line and a point, and you need to find the distance between them. So the distance is equal to the absolute value of AXA plus BYA plus C over the square root of A squared plus B squared, where the point A, it has coordinates XA and YA, A, B, C are the coefficients in the straight line D. Okay, a quick example, suppose you have the point A, which is 2, 3, and a straight line x plus 2y minus y equals to z, minus 1 equal to 0. So the distance is the absolute value of AXA. A is 1, XA is 2, 1 times 2 is 2, and so on. So this is the distance, and don't forget, of course, to rationalize your answer. And that's everything for our lesson. We are done. I advise you to watch the video more than one time. After you are done, you have to solve the worksheet, which is a direct application for what we have explained in the 2 lectures, because they are related. And don't forget that we have a quiz this week, so do your best.